channel under Physics Practical Theory and Teaching Methodology. Here we are presenting the Physics Practical under the Wheatstone Bridge. So from this question, the question said that you have been provided with 2 ohm standard resistor, yoke, wire W, battery, connecting wires, and galvanometer. Connect wire W with your 2 ohm resistor to make a loop. Make sure that the length of the wire W is 90 centimeters. At the junction C between wire W and the 2 ohm resistor connected one terminal of the galvanometer while another end with the jockey. Connect the wires from the battery E, one to the junction B between 2 ohm resistor and the wire W and the other to A. The length X is equal to 20 centimeters of wire W from the junction with 2 ohm resistor as shown in the diagram below. So we are going to connect our circuit as shown in this diagram. So here we have the galvanometer here. One end is connected with the wire W. This is wire W of resistance R. Okay. Wire W of resistance R have been connected, making a loop with this 2 ohm resistor. One arm goes to the switch and one arm of the switch goes to the cell, which is the negative terminal of the cell as it is shown in this diagram. The positive terminal of the cell connected to the wire, this one at this junction. So one arm of the galvanometer is connected to the yoke. As you can see from this diagram, also our circuit is completed like this. The question says that when the switch is on, slide a jockey through wire W. Slide a jockey through wire W to obtain the balanced point J. Obtain the length L1 and the L2. We have told that the length X should be 20 centimeters. As you can see from the diagram, the 20 centimeters is from the jockey, from the galvanometer to the junction point. So from the galvanometer to the junction point, you shall measure it to be a 20 centimeters. So make it straight, then you measure the length to be 20 centimeters. Centimeters should be here. So after 20 centimeters, you see there is a meeting with the wire, connecting wire. So after making your connection here, then find the balancing point on the remaining length of the wire W. While this one is fixed, then measure the length on the, obtain the balancing point on the remaining length of wire W. So here you can determine the remaining length. Okay. It have been balanced at this point. Then you can measure the distance. Measure the distance from that junction point to the balancing point. By means of a ruler, you can measure a distance. By measuring the distance, you can find out it balances at 15.4. Write down 15.4. This is in terms of centimeter. This is L1. So the L2, remember that the total length of a wire, it was 90. So 90 minus 20, it could be 70. 70 minus 15.4, it could be 54.6. So you shall continue by increasing the length of X as it is shown in this question. Repeat the procedure B and C by increasing the distance X by 10 centimeter each time to obtain 5 other readings. So each time you should increase the length by 10 centimeter. Means from 20 to 30 to 40, 50 and 60. After then, each time obtain the length L1 and L2, L1 and L2. So, according to me, I have the values. I've already obtained the values of length 1 and length 2. So length 1 in this column, and length 2 in this column. After then, the question says that find the ratio of L1 over L2. So the ratio of L1 over L2 in the table of results as it is shown in here. Measure the diameter of wire W. Hence determine the cross-sectional area of the wire. Diameter of the wire can be measured by means of a micrometer screw gauge. So by means of a micrometer screw gauge, you can measure, this is my wire which I was used. You can measure it by considering zero error in your instrument. Measure it correctly. So as you can see here, the reading is at 45. This circular reading balances with the micrometer reading. This one. So at this it is 45 in terms of millimeters. It could be 0.45 millimeters. So if that's the case, the diameter of the wire is equal to 0.45 millimeter. After determining the diameter, we should find the area of the wire. Area of the wire can be determined by taking the cross-sectional area of a cycle. So pi d squared over 4 could be the formula for finding the area of a wire, or you can use pi r squared. So you can determine it, or you can use it into a formula for finding maybe the resistivity of a wire if it is required. After then, plot a graph of X in vertical axis and against L1 over L2 in horizontal axis. Here also I have already plotted the graph of L1 X on the vertical axis and the L1 over L2 on the horizontal axis. My graph, I'm taking all the graph features. A heading contains of the respective units. Scale, in terms of vertical scale, I have 10 centimeter, 1 centimeter to represent 10 centimeter. In case of horizontal scale, 1 centimeter represents 0.5 times 10 to the negative 1 with no unit. This is my graph. As you can see, a graph is passing through the origin. Obtain the slope of the graph plotted in part 3 and use it to find the resistivity of the wire W. So how can we determine? By considering this circuit, as you can see that XC, if we use the ratio formula, X dividing by L1, this will be equal to 2 ohms resistor dividing by L2. X, we are talking about the resistance of wire X. So then, my aim is to determine the equation which used to draw this graph. So from resistance of wire X dividing by L1, this is equal to resistance of 2 ohms dividing by L2. But resistance of wire X can be determined by taking the resistivity of a wire X multiplying by length of wire X, then dividing by cross-sectional area of a wire. So length X of wire X here, as you can see here, X was varying from 20 to 60.